Hi, have you ever watched a movie where you saw a person sitting in front of their computer and all you saw going across their monitor were a string of ones and zeros and you were wondering what does this mean? Well, if you stay and watch this simple tutorial, you will learn how to convert numbers from binary system to the decimal system. Now let's start with a simple decimal number, and this will be 1337. To write this number, we add a small 10 to the bottom right corner, which represents a decimal system number. A binary system is based on the number of 2, and then we add to the power of 1, to the power of 2, and so on. I'll write this from the smallest number onwards, and we start on the right side, and that will be 2 to the power of 0. Then we have 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 4, 5, 2 to the power of 6, 2 to the power of 7, 8, 2 to the power of 9, and let's stop with 2 to the power of 10. You can go on. So 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16, then we have 32, 64, 128, 256, then we have 512 and 1024. How this works is, let's take the number 2 to the power of 4. Simple to write will be 2 times 2 times 2 times 2. So we have 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. That is how we get this number. Now let's move this away, and how we start converting our 1337 number to the decimal ones and zeros. The simplest way is to ask this question: does the 1024 go inside 1337? Of course, so we write 1 underneath, and we take 1024 as our base number to go on. Next question is, does the 512 go into number 1024, and those two together add up, do they go inside 1337? Let's find out. So we add 512. 2 plus 4 is 6, 1 plus 2 is 3, 5 plus 0 is 5, 1. And number 1536 does not go into 1337 since it's too large. We delete this and we write 0 under our 512. Now let's ask about 256. So 256, let's add those two up. So 6 plus 4 is 10, we write 0, 1 goes forward, 5 plus 2 is 7, plus 1 from here is 8, 2 plus 0 is 2, and 1. 1280 does go inside 1337, so we write 1 under 256. Now our new number is 1280, so let's write this here so that we don't forget, and let's delete this. So let's ask now if 128 is added to the 1218, does this go inside? So we put 128, sorry for this. So 8 plus 0 is 8, 2 plus 8 is 10, 1 goes forward, 2 plus 1 is 3, plus 1 is 4, and 1. Thus 1408 goes in 1337? No, since it's too large, so we write 0 under 128. Let's delete this one, and let's move to the next step. Does added 64 go inside that number? So plus 64, we have 4 plus 0 is 4, 8 plus 6 is 14, 1 goes forward, 2 plus 1 is 3, and 1 plus nothing is 1. 1344 is still a little bit too large for our 1337, so we write 0. Let's delete this once again, and let's go with the next number, 32. 2 plus 0 is 2, 3 plus 8 is 11, 1 goes forward, 2 plus 1 is 3, and 1. 1312 does go inside 1337, so we write 1 under 32, and we have our new number to go on. So we write 1312. So next number, 16. Let's add this up. 6 plus 2 is 8, 1 plus 1 is 2, 3, and 1. 1328 still goes inside 1337, so we write 1 under 16, and this is our new number. So let's add number 8 to that. 8 plus 8 is 16, 1 goes forward, 2 plus 1 is 3, 3, and 1. 1336 still goes inside 1337, so we add 1 under the 8, and let's continue with our new number. We add now the number 4 to our new number. 4 plus 6 is 10, 1 goes forward, 3 plus 1 is 4, 3, and 1. 1340 is a little bit too big for our 1337, so we write 0 under our 4. Let's continue with number 2. 2 plus 6 is 8, 3, 3, and 1. And 1338 is still a little bit too big for our number, so we write 0. Now let's add the last number, that is number 1. 1 plus 6 is 7, and we write down the other numbers. And that is exactly the same as our number, which means that we write 1 under 1. Basically what this means is 1, 3, 3, 7 in our decimal system is same as 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1 in binary. So I hope this was not too hard, and now let's convert this number back to this number. I will move this a little bit up if my computer will cooperate with me. So we have this binary number. I will put some space between numbers so it will be easier to explain this, and let's do it. 1, 0, 1, 0, 0, 1 1, I have a little bit more space, I said 1 1 1 0 0 1. And same as before, we are counting with 2 to the power of something, and this will be in representation on the decimal system from the right to the left. On the far right side is 2 to the power of 0, and this will be 1. Then we have 2 to the power of 1 is 2, but since here is 0, we don't count it. Then 2 to the power of 2 is 4, is again 0, we don't count it. And the next is 8, we count it since it's number 1 here. The next step is 16, then we have 32, then we have 64, which we don't count. We have again 128, which we don't count. Next step is 256, then is 512 and 1024. Now if we add all those numbers, we get 1024 plus 256 plus 32 plus 16 plus 8 and plus 1 is 1337 in decimal. Just to make it clear, I will write with another color the numbers that we did not add up, and it will be 2, 4, 64, 128 and 512. Let's convert another number, and this time let's do it with number 1 0 0 1 1 0. And once again we start from the right side. That will be 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5. And this will be 1, 2, 4, 8, 16 and 34. And now let's take this. Since we have in our numbers, we have 1, we have here 0, sorry for this, we have 0 1 1 0 0 1. Let's add up the numbers that we have and leave those ones that we don't have out. So we add number 2, number 4 and number 32, and this will be 32 plus 4 plus 2 is same as 38. I hope that this explained how we convert decimal to binary and vice versa. And if you have any other questions or questions regarding this video, feel free to leave a comment down below and leave a like if you enjoyed this video.